For standard 9th, we have already finished the factorization and we have finished the expansions. Now I am going to go to the next chapter, which is simultaneous linear equations. We know that equation of the form ax plus by plus c is equal to 0 is a linear equation. It is a linear equation. Like if I write 2x plus 3y plus 8 is equal to 0. This is a linear equation. This is a linear equation in x and y, and if I plot it, I'll get a straight line. If I plot this equation by giving different values to x and y, there will be innumerable number of values of x and y which will satisfy this equation of a straight line. So whenever we talk of a linear equation, then linear equation in x and y will have infinite number of solutions, because there will be many values of x and y on a straight line. On a single straight line, you will have many values which will satisfy the equation. So there will be infinite number of solutions. But when we talk of pair of linear equations, for example, if I say a1x plus b1y plus c1 is equal to 0, or a2x plus b2y plus c2 is equal to 0. Now these taken together will form a system of equations which is called a pair of linear simultaneous equations. These are linear simultaneous equations. And when we solve these simultaneous equations, we'll get two values of x and y. One value for x, one value of y. Because if there are two straight lines, they will cut only at one point. They will cut each other at only one point. One point will be common to both the equations. As I said, one equation, one linear equation has innumerable number, infinite number of solutions, x and y. Similarly, this another line, for example, this is line AB, it will have infinite number of solutions. There's another line CD, it might have another infinite number of solutions. But if they are going to have a common solution, if they are going to cut each other, they may be parallel to each other. But if they are not parallel to each other, then they are definitely going to cut each other, and then they will have one value of x and one value of y, which will satisfy both these linear equations, and that will be the solution of, that is called the solution for simultaneous equation. There are different methods. There are different methods of solving simultaneous equations. There are three methods which we are going to discuss by taking an example. I'm going to take an example for pair of simultaneous equations, and then I'm going to solve those simultaneous equations. For example, question is 4x minus 3y is equal to 8, equation 1, and the another equation is x minus 2y is equal to minus 3. Now the first method of solving this pair of simultaneous equation, these two, both these lines represent straight lines, and these straight lines will cut each other and they will give us a solution. Now the first method is substitution. From first equation or from second equation, we'll calculate the value of either x or y. Let me calculate the value of x. For example, and it depends which equation you pick up. I would rather pick up the second equation, because from here x can be calculated directly. From equation 2, you can pick up from equation 1 also. Let me do from equation 1. From equation 1. from equation 1. 4x minus 3y is equal to 8. So 4x will be 3y plus 8, or x will be 3y plus 8 upon 4. This is the value of x in terms of y. We have calculated the value of x in terms of y, and now this value of x I'll substitute in equation 2. Substitute x in equation 2. What is equation 2? X minus 2y. So where x is there, let us put 3y plus 8 upon 4, and where y, of course y will remain, y is equal to minus 3. Now let us take LCM. I'll take the complete LCM. 4, it is 3y plus 8 minus 8y is equal to minus 12. I have taken the LCM of left side as well as right side. Now what do I get? 3y minus 8y is minus 5y, and will be equal to minus 12 minus 8. So minus 5y minus 5y will come out to be minus 20. Minus 12 minus 8 will give you minus 20. So y will give us the value as 4. The value of y comes out to be 4. Now this value of y I'll put here in equation 1. You can put in equation 1 and equation 2, or here in equation this. This is not equation 1, it is equation 3. Substitute x is equal, because 1 and 2 we had assumed here. Now let us put y is equal to 4. Put y is equal to 4 in equation 3. In equation 3. What is equation 3? Equation 3 is x is equal to 3 into y, that is 4, plus 8 upon 4. 3 4s are 12, 12 plus 8, 20, 20 upon 4 is 5. So value of x is 5, the value of y is 4, and solution is always written as a pair of ordered pair, is written as a ordered pair. The value of x is 5, the value of y is 4. So this is your solution set. It is called solution set. Solution set. It's an ordered pair. It is an ordered pair, but this should be written as like this. X is equal to 5 and y is equal to 4. The value of x is 5, value of y is 4, and this value is unique for these two equations. Only this value of x and y will satisfy equation 1 and 2 completely. If I put x is equal to 5 and y is equal to 4, if x is 5, so 4 5s are 20, and if it is 4, 4 3s are 12. So 20 minus 12 is 8. Both sides, left and right sides, are equal, so this is satisfied. Now let us see the second equation. X minus 2y is equal to minus 3. If I put x is equal to 5 and y is equal to 4, so what will it become? 5 minus 4 2s are 8. So 5 minus 8 will give you minus 3. 5 into minus 8 will give you 3. Okay, we solved the simultaneous pair of simultaneous equation with the method of substitution. That is the first method we talked about. Now I am going to do the second method, same question, by elimination. Elimination. What is elimination? What are we going to do? Like this, 4x minus 3y is equal to 8 is equal to 1. First equation, x minus 2y is equal to minus 3 is equal to second equation. What I'll do is I'll make either x terms equal. X terms equal means the coefficient of x in both the equations equal, or I'll make the coefficient of y in both the equations equal. How is it possible? I'll multiply this equation with something, I'll multiply this equation with something. Now, if I multiply, how to make the x coefficient equal? Let me make first the y coefficient equal, because in this only I have to multiply one equation. I want to show you by multiplying both the equations. Like the coefficient of y is here 3 and the coefficient of y here is 2. 3 and 2. So we can make 3 and 2. What is the lowest common multiple of 3 and 2 is 6. I can convert 3y into 6y, and similarly I can convert 2y into 6y. How do I do it? I multiply equation 1 by 2 and multiply equation 2 by 3. Let us do that. When I say multiply by 2 and multiply by 3, that means we are going to multiply the complete equation, not the left hand side only or not on the right hand side. When we are saying multiply equation 1 by 2, that means we are going to multiply the complete equation by 2. And similarly, when we say multiply equation 2 by 3, that means we are going to multiply the complete equation by 3. And this is very important because most of the children make a mistake while multiplying. They might multiply this side, not multiply that side. So you have to keep in mind that we multiply both sides of the equation and the complete equation. Let me multiply by 2. 2 4s are 8x, 2 3s are 6y, 2 8s are 16. When you multiply with the same number on both sides, it doesn't change the equation because I can finally take out that common and divide it. When I multiply it by 3, 3x minus 6y is equal to minus 9. Now what has happened by multiplying, that your coefficient of x have become equal. Coefficient of x, y have become equal. Coefficient of y have become equal. And what do? I have to eliminate this. Elimination. Elimination is the method. So what I'll do is I'll eliminate y. How will I eliminate y? Because both have got the same sign here, minus 6y and minus 6y. So what I'll do is I'll subtract one equation from another. Like I'll subtract this equation. When I subtract an equation, the signs change. If I'm subtracting this equation from this equation, I am lower equation from the above equation, what will happen? The signs will change. It was plus 3x, it will become minus 3x. It was minus 6y, it will become plus 6y. It was minus 9, it will become plus 9. Now when it happens, then this will cancel. 6y minus 6y plus 6y will cancel. 8x minus 3x will be 5x. And it will come out to be 25. Because 16 plus 9 is 25. So x will come out to be 5. You got the value of x is 5. Now put x is equal to 5 in equation 1 or in equation 2, whichever equation you like. You can put it in this equation also, you can put it up in this equation also. If I put x is equal to 5 in equation 1, so 4 into 5 minus 3y is equal to 8. Or minus 3y will be 8 minus 20. 4 5s are 20, 20 will transfer to that side. Minus 3y is equal to minus 12, or y will be equal to 4. So your solution set is y is equal to 4, x is equal to 5 and y is equal to 4. From the first method also, by substitution method, we had got the same value. So x is equal to 5, y is equal to 4 is your solution set. It is not necessary to eliminate y. You can eliminate x. I'll show you by eliminating x so that there is no confusion in your mind. That how do I eliminate x? I eliminated y because I wanted to show to you by multiplying both the equation by some number to make the term equal. Because here only I'll have to multiply equation 2 because it is 1x here. When there is nothing, that means 1 is there. And I have to make it the terms, suppose x terms to be equal. When I say x term, that means the coefficient of x in both the equations should be same. So the LCM of 4 and 1 is 4. So I don't have to multiply this equation by anything. I have to multiply only equation 3, equation 2 by, now equation 2 by, what am I going to multiply by 4? I'm going to multiply equation 2 by 4. Multiply equation 2 by 4. The first equation is 4x minus 3y is equal to 8. And if I multiply it by 4, it becomes 4x minus 4 2s are 8y minus 12. Now both the equations have got the same value of x. Coefficient of x in the first equation is 4. Coefficient of x in the second equation is 4. But the question again is that this is plus 4, this is 4, plus 4 also. So to eliminate them, I will subtract. I will change the sign. Minus, plus, plus. This was plus, it became minus, it was minus, it became plus, it is minus, it became plus. So this term will be eliminated. You will get 8y minus 3y, that is 5y, that will be 20. So y will be 4. Y will be 4 like it was here. Now put y is equal to 4, put y is equal to 4 in equation 2. I am putting now in equation 2 because in the first I put in equation 1. Now I am putting y is equal to 4 in equation 2. So x minus 2 into y is equal to minus 3. So x will be 4 2s are 8 minus 3, x will be 5. So x is equal to 5 and y is equal to 4 is your solution of the simultaneous equation. So this was the method of elimination. This was the method of elimination. Now I am going to solve the same question by another method which is called cross multiplication. Which is also important by cross multiplication. We transfer all the terms to one side. 4x minus 3y minus 8 is equal to 0. X minus 2y plus 3 is equal to 0. We transfer all the terms onto one side. And then we write down minus 3 minus 2. The coefficient of y first. Minus 3 minus 2. Then this constant minus 8, 3. Then the coefficient of x, 4 and 1. And then minus 3 minus 2. Minus 3 minus 2. Please understand clearly. We will write first, like if it is, I'll give you an example. If it is a1x plus b1y plus c1 is equal to 0. If it is a2x plus b2y plus c2 is equal to 0. Then first you write b1, b2. Then you write c1, c2. Then you write a1, a2. Then you repeat this. Finish it with the same as you started, b1, b2. So we started b1, b2, the coefficient of y. We copy down the coefficient of y, minus 3, minus 2. Then the constant term, minus 8, 3. Then we coefficient of x, 4, 1. And then the coefficient of y, finish it with coefficient of y. Now we write it as x upon minus 3 into 3. Minus 3 into 3, which is minus 9, and minus 8 into minus 2 is plus 16. So minus 16 is equal to y upon, we have written minus 3 into 3, minus 8 into 3. Now minus 8 into 1, minus 8, and minus 4 into 3 is equal to 1 upon 4 into minus 2, that is minus 8, and 1 into minus 3 is plus 3. Why? Because it is minus. It is x upon b1 c2 minus c1 b2 is equal to y upon c1 a2 minus a1 c2 is equal to 1 upon a1 b2 minus b1 a2. That is the method. So x upon this, in between everywhere minus is there, x upon minus 25, y upon minus 20 is equal to 1 upon minus 5. X upon minus 25 is equal to 1 upon minus 5. So x will be 5. 25 will go up. Y upon minus 20 is equal to 1 upon minus 5. So y will be 4. So x is 5, y is 4. So whichever method you want to calculate, you can use any method, any of the three methods. Generally, the question does not say solve it by elimination, substitution, or by cross multiplication method. But for your practice, in the books it may be given that solve these questions by elimination method, solve these questions by substitution method, or solve these questions by cross multiplication method. Otherwise, generally in question paper it is not given like that. But in case it is given, you have all the three methods, and we are going to do some more sums for the practice after this. I'm doing this question of simultaneous equation by elimination method. 3x minus 5y is equal to 4 and 9x minus 2y is equal to 7. If I want to make x term equal, the LCM of 3 and 9 is 9. So I can multiply equation 1 by 3. Multiply equation 1 by 3. Sometime you will need to multiply only one equation. Like if I multiply here this equation by 3, then x term will become equal without multiplying second equation. But if I want to make y terms equal, then I'll have to multiply both the equation. So for simplicity, we should choose where we have to do the minimum work. And here I am going to multiply this equation 1 by 3 so that I get only to multiply one equation and not both the equations. So my work will be reduced. So I'm saying multiply equation 1 by 3. So let us multiply this equation by 3. 3 3s are 9x. 3 5s are 15y, 3 4s are 12, and this is 9x minus 2y is equal to 7. Now let us subtract. Because it is 9x minus 15y is equal to 12. It is 9x minus 2y is equal to 7. Let us subtract because both the coefficient of x or both the terms of x have got the same sign. When they have got the same sign and we have to eliminate, we must subtract. So subtract. Subtraction means change the signs. It was plus 9x, it became minus 9x. It was minus 2y, it became plus 2y. It was plus 7, it became minus 7. So this will cancel. Minus 15y plus 2y will be minus 13y. And this will be 12 minus 7, 5. It will come out to be 5. So y will be minus 5 upon 13. It will become minus 5 upon 13. The value of y has come out to be minus 5 upon 13. Now let us put the value of y in one of the equations. Put y is equal to minus 5 upon 13 in any equation, in equation 1 for example. In equation 1, 3 into x minus 5 into minus 5 upon 13 is equal to 4. So 3x plus 25 upon 13 is equal to 4. 5 5s is 25. Now transfer, so it will become 3x will become equal to 4 minus 25 upon 13. So 13 4s are 52 minus 25 upon 13 is equal to 3x, or 3x will be how much? 27 upon 13. So x will be 27 upon 13 into 3. So 3 9s are 27. So x is 9 upon 13 and y is minus 5 upon 13. We can check the question once again. 3x minus 5y is equal to 4. So we multiply it by 3. 3 3s are 9x. 3 5s are 15y. 3 4s are 12. And this is 9x minus 2y is equal to 7. 9x minus 2y is equal to 7. We subtracted the two equations to eliminate x term. We eliminated x term. Minus 15y plus 2y will become minus 13y. 12 minus 7 is 5. So y will come out to be minus 5 upon 13. Once we have got the value of y as minus 5 upon 13, then we put the value of y is equal to minus 5 by 13 in equation 1. What is equation 1? 3x minus 5y. So in place of y I am putting minus 5 upon 13. Minus into minus will become plus. Plus 25 upon 13 is equal to 4, or 3x will be 4 minus 25 upon 13. So we will take 13 as LCM. 13 4s are 52. 52 minus 25. 52 minus 25 is 27 upon 13, and x will become 27 upon 13 into 3. 3 9s are 27. So x is 9 upon 13. Y is minus 5 upon 13. This I have done with the elimination method. I'll do the next question by cross multiplication method.